I guess I'm going to have a go at putting these kits together. Banggood. This is a 100-watt power amp. Sure it is, but we'll see. I'm actually not going to run it as a 100-watt power amp, but probably get close. Not much to them. No instructions whatsoever, of course, as is typical for these kits. The PC board is all labeled, though. Hopefully I'll be able to figure it out from there. So I'm going to try to build these two up, and I'm going to use the standard approach. I'm not going to make you see all of this. I'll throw some stills in. I'm going to do the standard approach of putting the smaller components in first, the resistors, and then moving upwards to higher profile components. I'm not sure if I'm going to use the little screw blocks or not for the inputs and outputs. They may just get twisted wires. We'll see. Probably the twisted wire. I've got a unique little chassis to put these into to try them out with. So I'm going to temporarily put them in some nice chassis that they don't really belong in, and eventually build a chassis for them if I like them. Well, I've got the resistors put in now and the one diode. The only thing strange was one resistor spot labeled 680, and there was no resistor of that value. There was a 750. Both kits the same way. So 750 precision resistor went in both 680 slots. I think they're only 5%, or they're not precision, they're just labeled with numbers. But most resistors are 1%ers in here, which is kind of good, if you can really trust them. That blue on blue is kind of something else. Of course, resistors don't care which direction they're put in as far as current goes. I always put them in the same way on the whole board, so I can look at the whole board, and however the labels go, I kind of go with that scheme and put my resistors all left to right the same way, just for ease of reading, you know, and figuring it out if you have to service it. The other big question, a lot of people don't bend the leads at all, they have them sticking straight out and then solder them. Other people bend them straight and tight to the board and cut them, you know, short right at the board. Other people will put them in a row and bend them halfway and solder along the whole line at once, which is probably what I'm doing here. As far as whether you bend them tight to the board or whether you leave them splayed, there's pros and cons either way. If you leave them splayed a little bit out, it's much easier to service it later. If they're tight to the bottom, then they're really tough to service. You have to totally remove the solder, and then it still might adhere. So this makes servicing a lot easier if you have them splayed. But as far as electrical contact goes, if this was really my audiophile power amp I was making, I'd probably, you know, I was building a Tiger, I probably would push them all the way down and cut them short and solder them over. So it's kind of an economy to do it this way. Splayed a little bit, solder them whole rows, and then trim them. Next up is the capacitors. These little ones are going to go in immediately after the resistors are trimmed away. And I don't really have any direction on these caps. A lot of times the shield side should be marked. They really aren't. You know, I could trust the labeling. And I saw an article recently, you can't always trust the labeling anyway. If something really critical, I'd make a unit to test the cap, see which side is actually shielded. That's been addressed in a few different people's videos. And it's not a high impedance device where it's going to be real sensitive, like in, say, a tube amp or something crazy. You'd really want to be careful about having everything shielded properly. So I'll put the trimmed resistors, solder them, put the caps in, trim them, solder them, and be back. The capacitors in the one size come pre-formed to display a wider gap than they would normally display. And you have to undo that because the holes in the board are set for the narrow, not for the wide. A little annoying. You have to take a needle nose and straighten them out. Well, my quick little builds rarely turn out to be so quick and dirty. I built both boards to the point of everything except for the chip and the wiring, basically. And then I focused on one board at that point and wired it. Put the chip on, soldered in the chip. And of course I've been watching all my connections and stuff, making sure there's no bridge connections or anything. Could obviously use a rosin cleaning, but there's no nothing cold, nothing bridged. I even looked at the other PC board versus this one to make sure nothing looks, different as far as bridging goes. I looked at the capacitor placement, at least on the two big caps. Anyway, I looked at all that because it doesn't work. So here I've got a 60 watt power amp chassis, and I've tapped into its power supply to feed this guy. This guy can take up to a plus minus, well, I'll have to look it up to be sure, but it can take more than this amp. It can take it close to 50 plus minus. And this amp's plus minus 40, so that's fine. Ground's tapped in, speaker's tapped in. I left a little output coil in series there. That's not a big deal, that one fuse and all. I probably should have, in retrospect, I should have tapped right into the power so that I could install the line fuses. That'll be my next step, is to rewire the whole thing and, with over to the line fuses, so I can at least figure out if it's the plus or minus side that's pulling the current. But it's tough to, when you get that good of a short, it's tough to do a lot of troubleshooting until you get the short up a little bit. It's pulling the voltage down on this power supply, which should be 80 volts across the rails, plus to minus, should have 80. Only getting about 9 volts because it's being sucked down so bad by, the light from the massive current draw. So nothing's really heating up on the board. I did look at it with the infrared thermometer. The only thing that's heating up at all is the chip. So I hope I didn't ruin the chip. I did drop the chip in assembly. It fell, maybe 4 feet down to the cement floor here. That usually doesn't hurt anything solid state. But so I guess this is not going to be a one-part video, since now I got to troubleshoot this little. So basically I'm going to see which rail it's on, double check everything I can look at from that rail, and verify that the probably pulled that one pin on the chip that is the rail in question, and make sure it's the chip itself that's shorted. If not, I'll see if there's something on the board strange, but it's unlikely. Did have to manhandle those little caps a little bit, these yellow caps. First of all, there's two different sizes, which I didn't notice at first. I thought they were all the same size. Started jamming them on, I had to move one back to a different hole. But mainly I had to straighten them out. I showed how the legs were splayed. You have to really work on the legs to get them back narrow again, get them in the board. But I didn't see those caps heating up. I did look with the thermal, and none of the caps were heating up. So I don't think it's a capacitor backwards or shorted or defective. The only thing it can be is a chip, really, or some unknown defect in soldering. But I've looked at all that. There's really no bridges, nothing even. But I'm going to put a bookmark in it. I'm leaving this area for now. I'll look at it again next week. It might actually be a week and a half. I'm going to have to stay south and take care of some taxes and stuff like that. At least get started on a lot of business stuff. This is the suggested schematic from the data sheet. And here's the data sheet So it should be able to take the, actually says it can take a 50 volt rails here. The kit says 35. The capacitors in the kit were 50 volters. So I don't see any reason why this couldn't run on 40 volts. It would take darn near 50 volts to get, 100 watts out of this. Should stop some of these, let you see them. Whoops. Sorry about that. And this is the website. ST, a bit about it. It's pretty much just a summary. And Banggood, it is this kit. The caps aren't nearly as big as what they show here. The built there is kind of sloppy too. This is 32 volts here, which is giving it split 40s. The specs say split 50s though, and you have to have split 50 to get 100. There's no doubling. It's not a bridged output. It's a single-ended output. So that's why I was figuring when it has to be able to take 40 volts easily. So I'm not sure why mine tried. I will try the other one next time up there. I'll finish up the other one, see if we can get that one to work. Maybe it's because I dropped it. Maybe there's a phantom short. So if I do find that the chip is shorted on one of its rails, then I'll finish this one up and try it out. And I guess I'll buy another chip if I get this one working, the other one doesn't work.